Yellowstone Supervolcano's deep secret revealed by satellite images. The satellite images acquired by ESA's ERS-2 revealed the recently discovered changes in Yellowstone's caldera are the result of molten rock movement 15 kilometers below the Earth's surface. That's about 9 miles, 7 to 9 miles. According to a new study published in Nature magazine, they use synthetic aperture radar interferometry, INSAR for short. Charles Wicks, Wayne Thatcher, and other U.S. Geological Survey USGS scientists mapped the changes in the northern rim of the caldera or the crater. As we know, that's in the northwestern part of Wyoming. And we know that we're going to look at some geodesy to see how that is inflating now. That's towards the area of Hebgen Lake, where they had the 7.5 magnitude earthquake in 1959. So U.S. Geological Survey scientists mapped the changes in the northern rim of the caldera or crater and discovered it had risen about 13 centimeters from 1997 to 2003. INSAR is a sophisticated version of Spot the Difference, and it involves mathematically combining different radar images acquired from as near as possible to the same point in space at different times to create digital elevation models and reveal otherwise undetectable changes occurring between image acquisitions. Thatcher said, "We know now how mobile and restless a volcano the Yellowstone caldera actually is. Ground-based measurements can be more efficiently deployed because of our work, and the research could not have been done without, of course, satellite radar data." The last super-eruption happened about 640,000 years ago. A massive volcano erupted in Yellowstone, creating the caldera. It measures some 45 kilometers wide, 75 kilometers long in the center of Yellowstone National Park, and at the same time, the northern rim of the caldera began rising, referred to as the North Rim Uplift Anomaly, NUA for short. Support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. This is the rim of the caldera, as we can see. Now, in 1997, the floor of the caldera began sinking. According to the article published 2nd of March 2006, the floor sank as the molten rock, the magma, flowed out of the caldera into the Yellowstone volcanic system. The uplift of the caldera's rim is theorized to have occurred even as the floor sank because one of the natural valves, which allow the magma to enter into the volcanic system, was unable to accommodate the increased flow of magma, causing it to accumulate beneath the North Caldera boundary. The magma movement may have also triggered the sudden rise in temperatures at the Norris Geyser Basin and the eruption of the Steamboat Geyser in 2000. The world's largest geyser, Steamboat, had been inactive at that up to then for 9 years. Now, the disturbances in the geyser during that 3-year period are not unique to Yellowstone's history, but as stated in the article, this is the first time the changes in the deformation field in the park suggest a cause and effect relationship thanks to the use of INSAR data. Despite the activity in the caldera, Thatcher said the likelihood for a magmatic eruption is extremely low. However, the area poses other potential risks. The possibility of a steam-water explosion, or phreatic eruption, as it's called, is perhaps the greatest risk. Its effects would be quite local, but still potentially dangerous, he said. Having access to data over long periods of time is important for scientists to identify and analyze long-term trends and changes. ESA now has a 15-year archive of homogeneous data thanks to the continuity of the satellites ERS-1 and ERS-2 and NVSAT. And NVSAT and ERS-2, with a difference in overpass time of 30 minutes, are continually adding to the archive. Thatcher said, "The complete aerial coverage and frequent repeat satellite passes creates a unique suite of deformation measurements of restless volcanoes worldwide. They are particularly useful in remote and inaccessible areas and will continue to monitor Yellowstone with INSAR imaging, he said. And this is sourced from the European Space Agency on vis.org. And now we'll go to the geodesy to see how the deformation of the area of Yellowstone Supervolcano is taking place, what's going on there. We are at geodesy, and all these are the GPS stations. This is the area of Yellowstone Supervolcano, and this is Hebgen Lake at the area of about a quarter or a fifth of the Caldera. This is the Caldera, you can even see the rim of it. And this is Hebgen Lake in the area of Idaho, Montana, and this is the border of Wyoming. So let's go to some of these areas here. Let's go to the Yellowstone Lake area, GPS P709 to see the motion there. Okay, if it goes, this is the east-west graph. If it goes up, it means it's going east. It's not going up, it's going since 2006 to 2000 now 22. It's going down, it's going west, as we can see. This is the north-south graph. It's not going up, showing it's north. It's going down, meaning it's going south. So the deformation shows that the land is going, it's in subsidence, going, not subsidence, sorry, it's moving southwest, and basically seasonal to steady as far as deformation is concerned. So this one here is at the east of the lake. Let's go to this part of the lake, to the southwest. Again, it's going southwest, and it's not a very good graph to see here. Let's go to this one here, to the west of the lake. Again, southwest movement, and you can see a tremendous amount of deformation, deflation in 2004, inflation, millimeters up to 2010, then starting deflation, and then rapid inflation up to 16, sorry, and then deflation up to now. So you can see that as a tremendous amount of movement there at the west of the lake. Okay, it's going southwest and every which way. Now let's go to something in between Hebgen Lake. This is Hebgen Lake here, as you can see. Let's go to the sat image. You can see that. Okay, that's Hebgen Lake, and this is the Yellowstone Lake, and that's the Caldera area, and all this is the supervolcano. Let's go back so we can see it a little bit better. Hebgen Lake, what's happening here? Again, it's going southwest, and the inflation, deflation is everywhere. Let's go to this one. Hopefully this graph is better. Southwest and steadily inflating. So this area, as we can see, as the sat images showed, the northwest part of the supervolcano is inflating. Let's go to this one here. Again, southwest and inflating. Okay, so we can see that the northwest part of the supervolcano is inflating. And this one here, southwest and inflating. Now, okay, it's inflating. The thing is, though, it's not just the magma that we have to worry about. From one of the videos that I posted a few hours ago having to do with how a supervolcano can erupt, it also has to do with the chamber roof, the magma chamber roof, and cracking and faulting from seismic swarms and earthquake swarms. They can cause the roof to crack, and that would cause an eruption. The supervolcanoes don't act like regular volcanoes. They have another type of mechanism. So it's not just the magma that we have to worry about. And in fact, the geologists were saying this is something that the Yellowstone or other supervolcano geologists have to think about, how to measure the status of the magma chamber roof as far as quake swarms are concerned. What happens, what's happening, how can we tell what's happening, and what the condition is of the magma chamber roof. So let's go now a little bit here towards Montana. Again, it's going southwest and inflating. So this is what's happening here. Let's go here, Gardner. Southwest, and a little bit more of activity, inflating, deflating, inflating. So, and a little bit around Big Sky. That's not a good one. That's not a good one. Let's go here in Idaho. Okay, southwest and sort of deflating, inflating, seasonal. So around Hebgen Lake, we see that it's inflating very steadily. Southwest and steady here. And this one here, southwest and inflating very clearly. So I'll leave links below for you for this. The geodesy map has all the GPS stations worldwide so that you can see what's happening in your area as well. Please leave your comments and thank you for your support.